Swayam Prabha. Digital India. Educated India.
Hello everyone and welcome to new discussion which is on essential components of GIS. Very briefly, when we were discussing what is basically GIS, indirectly we touched these components, but here now we will have a full or detailed discussion about this. The figure on the right side, we have already discussed that the real world can be segmented into different layers, and these layers represents the different types of data which we handle in a GIS platform, like point data, line data, polygon data, raster data, images data, and so on and so forth. So generally, as we know that in GIS the data, spatial data, is organized into layers. One important point which I want to mention, whenever I mention in this discussion related with this course GIS, whenever I say data, I always mean is I am talking about the spatial data. Now there are basically in different literatures, books, or on even the web pages, you may find that people are having different number of components against the GIS. But I find that these 5 components are best represent what is basically GIS or components of a GIS. Like every system will have its own component. Like if I give an example of a computer, say desktop computer will have a screen, will have a keyboard, will have a mouse, hard disk, and a processor, and many other components also. So similarly, GIS is also having components. The best we can have, and more or less now people are agreeing that these components can be divided into 5 categories, and basically as shown along a circle. So each component is important. We cannot say that this is the first component and this is the second component. So that is why it is shown, the cyclic thing is there. So I start from this bottom left, that hardware. You need to have, because by definition as we know that GIS is a computer based information system. So you need to have hardware, of course you need to have software, and then comes the data. Here I would like to give an analogy which is like GIS is a carpenter's toolbox. Some people will laugh on this, that what kind of analogy is this. But of course carpenter toolbox is not a computer based design or computer based system, but let me elaborate on this, that this carpenter's toolbox will have only tools like software tools. So the GIS, carpenter will have the hardware tools. In GIS we are having software tools, but tools, this is what is. But the carpenter's toolbox will not have the data. So data there is missing. On GIS platform also, if you developed if you get a proper hardware and install a GIS software, which are many, then it will still you will not have any data on your machine. So your toolbox, which is including hardware and software, do not have any data. The same way as carpenter's toolbox. So it will have different tools like hammer, saw, drill machine, and all those things, but it will not have wood, mica, and some glues, and so many other things which are required to prepare a furniture. And second thing, that carpenter's toolbox will also not have a design part. How to design a chair? I can buy a carpenter's toolbox very easily in the market by paying few thousand rupees, but the design of a chair will not come, design of a table will not come. That has to be developed from somewhere. Some expert has to be there, or some experienced carpenter can design a thing, or a user can provide the specification that I want table of this height having this length and width and made from this material. Now that carpenter will prepare according to user defined specification. Same thing here we are doing, that a GIS expert will prepare maps or data or analyze the data as per user defined specification. The GIS expert can suggest that in order to have that kind of design or map, you require this kind of data, and this data may be available from these sources. Like a carpenter can suggest you that if you want to buy the raw wood, it is available at this shop. If you want to buy the mica or glue, these are available at this shop. But otherwise, after installation of a GIS software on a computer hardware, you still do not have the data. As recall the definition, data coming from variety of sources. So, it is not residing on your machine initially, it will come from variety of sources, and then you organize and make it in such a manner that you can apply the design or user defined specifications for analysis and modeling. And finally, of course, comes the people. People are at every stage, for handling softwares, for maintenance of hardware, for generation of data or analysis of data, and of course the method and procedures towards the development. And top of these, the decision makers are most important, because they are the real users of GIS, and they are basically compelling since beginning of the development of GIS for further development of GIS, because they keep asking questions, they keep asking new products from GIS, and GIS experts keep looking either the tools or methods available within that GIS platform or in other domain. Lot of things might have developed in mathematical domain or in computer science domain, which has not yet been incorporated into GIS. But if users are looking certain solutions, and if we know that people have already developed that kind of thing, then it can be incorporated. I will give you one very common example of this, like wavelet. It was wavelet theory. So, first it was in the mathematics, then it reached in the computer science, coding started, and now wavelet is being used also for digital image processing or in GIS, and also for data compression, which is again a very common part of GIS. So, something which is developed in mathematical domain may not directly be incorporated into GIS, but when it goes to the computer scientists, they develop, they code, create software, or they incorporate with the GIS software, and further your GIS software or whole GIS technology becomes much more powerful. So, there are many such examples where things have been developed on different domains and then they have been incorporated into the GIS platform. Now, we will look these components one by one. Hardware is basically a computer on which a GIS resides or a GIS operates basically. Now, what it basically is, hardware can be a very high end workstation or some other machines or a server, or hardware can be even nowadays smart mobile, which is also shown in this slide. So, from a big computers or workstations or servers to your mobile, all kinds of hardwares now GIS softwares are available, or custom designed GIS softwares are available, which can work on these different hardwares which is available today. So, GIS can run on a wide range of hardware types, from centralized computer servers or to desktop computers to smart mobiles, including now even smart watches. Some stripped version of GIS or very small utility of GIS is available, standalone GIS or network based GIS, and then you use the GIS. And so, the hardware now varies, having a wide range of hardware types on which GIS can run. Next is the next component, very important component of the software. When I started discussing about the historical development of GIS and in the previous lecture and discuss about that how Roger Tomlinson, who is known as father of GIS, he basically developed initially the software, that is the Canadian GIS or CGIS. So, the software is very much part of GIS, and GIS software provides the functions, tools which are required to organize the data, store the data efficiently, and of course analyze and model and display that data or that geographic information as per user defined specification. So, software is equally important as your hardware. And key components of the software, or you can say sub components of GIS, are the tools for input data, because sometimes data may come in front of you in an analog form, a table, a register, some organization have noted the data. Now you have to convert into digital format. So, maybe it has to be typed even sometimes. Yes, all data today, even today, it is not available in the digital format or in organized fashion. So, we have to bring the data. So, our GIS software should be capable of allowing data to input into the database, GIS database. So, input tools must be there. Sometimes we are having a map in a print form. Now, we want to bring into on a GIS platforms, that has to be digitized, and for that also the tools software tools should support. And nowadays these modern GIS softwares, most of them supports the input or digitization of maps and other geographic features. Manipulation does not mean that fiddling with data or creating errors with the data. No, not at all. Manipulation means changing from one format to another, and maybe changing the the way the data was originally collected to the data which is suitable for this. And manipulation might be the original data may not have the location, but now I want to make it as a spatial data. So, I will attach location with each data set. That location might come through field investigations and using the GNSS receivers. So, everything, these tools must be available in a good GIS software. That is what the components here is. Database management system, each GIS software either will have its own database management system which can be used, but for a large data analysis, or when you are having huge amount of data, and then probably, or people say big data, then you have to, maybe sometimes you have to resort to the external DBMS systems like Oracle and other things. So, if I give an example of ArcGIS, which is ESRI, Environmental Science Research Institute, is a private company. Commercial product is nowadays called ArcGIS, and ArcGIS supports to a large extent its own database management, and it is having own system. But if data is very big, then you would find limits within ArcGIS. So, then you have to resort to some external GIS or database management system, like I gave the example of Oracle and its other. Also, the software, a good GIS software should also support the query. Once the database is there may be query of one type today, but tomorrow some other user may raise a different query from the same data. So, we need to efficiently retrieve the data, and that can only be done if data has been organized in a proper manner. And then of course, once everything is organized, then our GIS software should also support analysis as far as possible. All types of analysis, even with the software which I gave the example, may not support. So, like suppose if I want to do analysis related with the air pollution, now special tools may not be available which mentions that for air pollution analysis you use this tool, but basic tools are available. So, if I know the inside of GIS, or when inside is out of GIS to me, then even using basic tools I still can perform analysis. So, that the analysis part is very important. Earlier we used to spend lot of time to create the database, spatial database on a GIS platform, because in early stages of the development of GIS, lot of data was not available in digital format and not organized with geographic locations. Now large amount of data is becoming available which is organized and which is geographic data. Like for example satellite images. Now the lot of satellite images are available free of cost and they are georeferenced. That means the geographic coordinates are now inbuilt in those images after the initial processing by the data those who have acquired the data. So that analysis, that processing I do not have to do now. I just download the image and it is ready to use on a GIS platform. Similarly, many other data sets like census data or groundwater data or meteorology data, lot of such data sets are available now in organized fashion compatible with GIS platform, can be used directly on a GIS platform. So that now instead of spending time of organizing or creating a special database on a GIS platform, now we can spend more time on analysis, because analysis is really the part where we should spend lot of time and learn different tools and techniques, and analysis which is being done in other domain may not be today in GIS. So we should try to incorporate how we can perform such analysis on a GIS platform. Bridging the gaps which are in different domains which are available, and of course visualization is very much required. So in form of either maps which people prefer many times, because you know that a very old saying is a picture tells 1,000 words, and I have added into this phrase that a picture tells 1,000 words and a map tells 10,000 words. So people prefer because we can visualize things, we can see the pattern, we can see the distribution, and along with some other data sets. The example of that corona epidemic. So we, as soon as the data was plotted, people knew that which well water is causing problem to the resident of that area. So visualization in form of maps is always preferred by many people. Otherwise charts can also be created, or other graphs or tables and other things can also be created on a GIS platform. So the second component is equally important as first component. Once you have set up or got a hardware, rest of the things are fixed, but the software keep getting updated and becoming more richer and richer. So and new tools can also be developed. Another important point before I go to the next component regarding the software, if you are thinking to have your own GIS system or would like to install or buy a GIS software, then you should look at GIS software which is having possibilities of appending further tools in it. That means it should support some outside programs to which I can integrate with existing installation, because that will allow me to do many other analysis which a standard installation may not support. So that is one thing which one always should look. Another thing which also one should look, if you are going for a choosing a GIS software which are different, many are available in thousands, then you should also see whether that software is in public domain or a commercial one, or a open source or commercial one. Because for commercial one you may have the support from the company, but open source sometimes you may not get support. I am not against the open source, but these are the difficulties sometimes you may encounter. So these are the things are there. I will give you one example of open source GIS which was there since ages. It used to called as GRASS, GRASS, and it was developed by US Corps of Engineers like NCC in India, and those people developed this software. It was available free of cost, but people faced, including myself when I started using GRAS, we faced the problem of getting support. But nowadays things have changed, and QGIS is one of the best open source GIS software available. Anybody can install and can use. It is a very good software. It has got lot of support, discussion groups, all kinds of things are available with QGIS also. And QGIS will, whatever the tools, software tools which I have discussed is having, I have seen it is having. I have used that one and it is all having as commercial GIS. So, it is not that commercial GIS should always be used, no. If your work can be done using a open source GIS, that is wonderful. Now, when GIS was developed in 1964 and onward by Roger Tomlinson, it was not, it did not have the graphic user interface. That means everything was in command mode. So, we used to type. Even when ArcInfo came on a desktop machine, like in name of PC ArcInfo, everything was in command mode. So, whenever we want to display, we had to type and give the instruction or commands to the software. Now, after this invention of mouse and graphic user interface, the accessing tools, that means software tools and data, has become really very user friendly. And that is the biggest user friendly development which has taken place in the GIS domain is this graphic user interface. So, it has become much easier, much user friendly as 20 years back. The heart of GIS is the data. I am talking about spatial data. Without data, it is something like a carpenter's toolbox, having tools but does not have the material to prepare or manufacture a furniture, and it does not have the design. So, if we talk about this material, then material in GIS is data. As rich your GIS database can be for a enterprise or for a organization, then you can do lot many analysis on it. But if it is not rich in data and good quality data, clean data, then such analysis cannot be performed. So, possibly the most important component of a GIS is the data. I would definitely repeat again that if I have to put in hierarchy, then it becomes very difficult to say that hardware is least important or data is most important. But still, without I can buy a hardware, I can arrange a software or buy a software or open source software. But if I do not have the data, everything becomes non-usable. So, that is why here it is mentioned that possibly the most important component of GIS is the data. Now, geographic data or spatial data and related tabular data. Data in GIS we divide into different categories, but two main categories initially data. One is the geographic data or spatial data, another one is also called non-spatial data or tabular data. Tabular data because when we display, it is displayed in form of tables like Excel sheets. So, that is why it is called a tabular data or also called non-spatial data or also called attribute data. So, each spatial data can have as many as or n number of attributes data depending on type of data and requirements. For example, if I am having earthquake epicenters, so location of earthquake epicenter becomes my spatial data. What is the magnitude of that earthquake, at what depth it has occurred, and what are other details about like fault plane solutions or geology or other things, that will go as a attribute data. And there is a direct linkage or a dynamic link between spatial data and non-spatial data. What I mean here, if I do a query on tabular data, the same time the same selection is done on the spatial data. Vice versa is also true. If I perform certain analysis or query over my spatial data, the same time it is also shown with my tabular data or reflected in my tabular data. So that is, these two data sets, one is spatial data and non-spatial data, they are integrated in a manner that they goes hand in hand. And whenever I want to use it, one data or query one data, another is automatically is also queried. Now data can be created by ourselves going in the field or collecting elsewhere, or can be purchased from a commercial data provider. So lot of data now also available through companies which collects the data, organize the data, and they make the data GIS compatible. Or nowadays lot of web portals are available which also provides data many times free of cost. I gave the example of like remote sensing data, satellite data of various satellites of various countries on daily basis. It is available. As soon as the data is acquired by the satellite, let me give you an example like Landsat 8 series. As soon as the data is acquired, in 10-15 minutes time, automatically that is available for download, and that too in a organized manner. Organized means it is already geolocated or georeferenced, and it directly you can bring onto a GIS platform. And there are satellites which may provide data on daily basis or hourly basis, and that too in organized fashion. Many times you can download free of cost. Or otherwise, if it is not available, then there are commercial providers. Sometimes when these resources get exhausted, you do not find the data, desired data, either through your free or commercial providers, then you have to go in the field and collect the data. So data can come from variety of sources, remember that thing. Now what is the basically what GIS is doing, as we have been discussing, that GIS will integrate spatial data and other data, your tabular data, non-spatial data, data from other sources, and in a DBS or in a database management system, and then this organize, maintain their data and manage spatial data. Now fourth, and again very important component, because without users, without people, GIS is nothing. So it is equally important. All 5 components are equally important. So the people, users. GIS technology is limited without the people who manage the system, who run the system, develop the tools, develop the bridges between different domains, mathematical domain to GIS, mathematical domain, computer science and to GIS, and many other disciplines. Somebody might have developed a hydrological model to predict discharge on a river stream. Now can I use or can I import, can I decode or recode in a way so that I can also use on a GIS platform. So you need expertise, either external or yourself, to integrate that model into a GIS. So such understanding or models may be available in other domains, one has to only bring it in. And of course people develop plans for applying it to real world problems. I am looking for groundwater or some mineral resources or petroleum. Then I plan my exploration using GIS and using different data sets. The data set might be satellite images, data set might be the digital elevation model, data sets might be the borehole data or log data. And then I try to analyze and try to see and other knowledge, geological or geophysical knowledge, and then I try to estimate that where I can find the water and how much water I can find, how much I can bring on the surface. So many such things can be done by the people within the GIS. So real world problems can be solved. First, as in the previous lecture, in the last slide we had the project development of GIS. So first, to understand the problem, what are the key components of the problem, what are the key parameters, and then try to organize those things on a GIS platform for analysis. GIS users, there are a variety of users, range from technical specialists who design and maintain the system, to those who use it, just user, to help them perform their everyday work. Let me give you again the same example of like Uber or Ola apps. We are simple users. We are not a technical specialist or we are not as a developer. But our experiences, our feedbacks give feedback to these specialists or developers to improve their system further. And so we are not designer, but we may suggest sometimes that if you do this thing, if you add this also in your app, then it may become further useful. So the feedback or the questions which user raised always compel a better development of a particular or custom designed GIS software. So users can come from variety of places or variety of range and of technical specialists. So the decision makers are also users. Users, those who are maintaining the GIS system, they are also users. Those who are developing GIS softwares, they are the technical specialists and so on and so forth. So people, they are all people, they all are contributing towards, even users are contributing towards the development of GIS. Without users, GIS is nothing. Now hardware and software have been tremendous development have taken place in these two domains, which made people easy to run the GIS software. As I have been mentioning that initially when GIS was developed in Canada, it was on DEC 20 machines and the programming language was Fortran. It does not have the graphic user interface and a very limited hardware capabilities and of course software capabilities. It used to only handle initially vector data because Roger Tomlinson was given task to maintain these networks which were available within the municipal boundary of Ottawa. So he developed only that, but later on the vector data, along with vector data, raster data handling also became, and now lot of variety of data can be handled on GIS. But these two major things, vector and raster, and of course non-spatial data. So vector and raster comes under the spatial data category and attribute data comes in non-spatial category. All these types of data can be used on a GIS. So the development as today, if more development takes place in computer hardware, which is happening almost every day, after some times that is percolated into the GIS. Same, more software tools, better language, better programming, more efficient programming is done, and then that also percolates on a GIS platform. Let me give you an example. I have already mentioned that initially the GIS was developed in Fortran programming language. Nowadays not many people use that language. Later on, like if I take the example of this ArcGIS, ArcInfo was developed on a Unix platform and that visual some different languages. Then they started using this, initially it was on C++, then they started using Visual Basic. And nowadays there is another language, Python. So lot of development which one can do on Python can also be integrated and onto a GIS platform. So a particular software can have has been developed on a particular language, but it can also accommodate the development which is being done or has taken place in other different languages. So if somebody has developed a tool, software tools for GIS analysis in C++ or Visual or Python, can be integrated into a current GIS software like ArcGIS and many such software. So the development which takes place in hardware and software domain is coming directly into GIS development, and GIS tools or GIS technology is enriching from these developments on daily basis. And last point here is the people are main component for the successful GIS. Successful GIS means having installation, having spatial data, and now I have started producing through my analysis various scenarios, various results, maps and other things. Then only it would be called as successful GIS. And last component in GIS are the methods. The methods, because this is these are the algorithms. There might be some algorithms, there might be some equations or some models already developed in different domain. All those can be incorporated, may not be today, but after developing better understanding between GIS developer and a domain expert, and these methods can also be incorporated into GIS. So, a successful GIS basically operates according to a well designed plan and business rules, which are the models and operating practices unique to each organization. So, depending on for what purpose GIS is being used, for which the models and operating practices will be developed, and accordingly then successful operations of GIS will take place. So, suppose if somebody is working for a company which is related with the development of highways and roads and other railway tracks, so they will be using GIS only for that purpose. But if somebody is working for an organization which is exploring the natural oil or gas, they might be using the same GIS software, but their data set might be completely different and their methods, approaches, operation practices, business rules may be completely different. So, the software hardware might be same, but users, because the applications are different, users will develop their own methods and analytical tools to fulfill their own organization requirements. So, any organization has documented their processes, plans for GIS operations. If I install GIS software, like I gave the example of say ArcGIS or QGIS, everything is installed, but whatever the tools which are available. But at the end of the day, I might be, if I am working say for groundwater exploration, I might be using only 10-20% of those tools. But the same software installed, if it is with civil engineer, he might be using different tools, maybe again 20-30%. So, that documentation can be done by different organizations, different departments for their own purposes, so that it can be used by the future generation people, that this software and these tools are specific to our organization. And these documents address number of questions about the GIS methods, number of GIS expert required, GIS software, hardware, process to store data, and what types of DBMS and more. Because a big enterprise or organization should follow certain business rules, and among these rules are documentation. So, that a employee today is working for a organization, tomorrow he may leave, some new person can come. So, it should not happen that that person is gone, so everything is gone. No. If it is very well documented, like along these lines, the number of experts required for a certain project, what are the software, what are the hardware and processes to store the data, what type of DBMS and methods, if everything is documented, a new person can adopt very quickly and can work on this. And a well designed plan will address all these questions. So, everything, if it can be planned properly, then it becomes really a successful GIS. Now, these we have been using word GIS thematic layers and data sets. So, I will spend few more minutes on this, that GIS organizes geographic data into series of thematic layers and tables, and the data in a GIS are reference to geography, that is their spatial location. They have the real world locations, that is again in geographic coordinates, and could overlay one over another. Sometimes the term geospatial data is also being used. So, geospatial data means spatial data means having geographic location. I earlier mentioned, so very quickly I will cover these 2 points, that 2 main components of the data or 2 types of data which we handle in GIS, 2 main types of data. One is the spatial data which is having geographic location, and we can answer a question, where is it? So, whenever there is a question related with location, that will come through spatial data. And if we have a question like what is it, then that will come from the non-spatial data. So, GIS data can be divided into 2 main categories, spatial data and non-spatial data. Spatial data can answer questions related with location, and non-spatial data can answer questions related with what it is and so on and so forth. Now, representing this part, that real world can be segmented into different components, different layers, this means different themes, thematic layers in the. So, real world can be also segmented depending on type of the theme which you are handling, like vector data or maybe the raster data. Raster data you can very quickly understand as in a form of grid, but the grid and image are 2 different types of raster data. And in case of vector, there are 3 different types of vector data. Vector entities of vector we have studied in our high school or 10+2. The same concept of vectors are there, that there is a origin, there is a destination and direction. So, this distance becomes our magnitude like in typical vectors, and the origin and destination is known, so we know the direction also. So, the same concept, but only thing is that here we are having 3 types of vector data: point data, line data or polyline data, a typical vector, and polygon. So, we will be discussing little later about those. So, this brings to the end of this discussion about the different components of GIS. Mainly 5 components are there, and different components are important, and we cannot put in any hierarchy, all are important, and thank you very much.